Hello, good evening everyone. Welcome to BYJU'S exam prep. So today we are going to discuss our second session of the EMFT where we are going to discuss about the reflection coefficient and your S parameter. So guys, please share the session with all the other friends. Here we are going to discuss the two important topic of the transmission line. As you know that there are we have 26 topics in this special 26, and we are going to cover the topics, two topics at least every day, and each faculty is covering almost two or one topic of each subject, so covering around 26 topics. Okay. Hello Ankit, good evening. So let's begin the session with the small introduction. That is this is me, Saket Verma, and I'm having more than 13 years of experience. And I have done MTech from IIT Guwahati and cracked a different PSU exam as well. And I'm having a mentorship. I have done mentorship of the lakhs of students in my subjects, and I have taught the subjects like electromagnetic theory, communication system, advanced communication system, signals and system, and ICT in the last 13 years. And communication and EMT are these the Telegram group of my yes, Sandesh. Good evening, Vikram. And now this is my Telegram group. Here you can join me to if you want any suppose guidance, personal guidance. You want one-to-one interaction. If you want, then you can join this Telegram group. And guys, there is a very important announcement that we have produced the very good rank in the UPSC ESE, so you can become a part of our branch. Yeah. So before starting the yes, Akansha, good evening. So guys, first of all, what is reflection coefficient? So we calculate the ratio of the reflected wave divided by incident wave, and the ratio of the reflected wave divided by incident wave is nothing but the reflection coefficient. Okay, so when we suppose give the input to the transmission line, the generated voltage is VG generator voltage, and the ZG is the impedance, and the current is suppose I naught. Then suppose this current is flowing in the forward direction, that is V naught plus, and if this load impedance is not equal to the characteristic impedance of the line, then some part of the incident wave can reflect from the load. So in that case, we calculate the reflection coefficient at the load and also at particular distance L. Suppose I ask you to calculate the reflection coefficient at load, then you will substitute the distance Z is equal to L for load. Okay, and at the load, the Vz is nothing but the value VL, and the current is having nothing but the current is IL. So in this voltage equation, if you will see, so this part is showing your reflected wave and this part is showing your incident wave. So in this way we will calculate the ratio of the reflected wave divided by incident wave. So the what is the reflected wave? Reflected wave is V naught minus e to the power plus gamma z, and because we have substituted z is equal to L, so we will get the L over here, and V naught plus e to the power minus gamma L. Okay, so in this way we will get, so V naught minus divided by V naught plus e to the power 2 gamma L. That is the reflection coefficient we are getting. Now, how do you calculate the ratio of V naught minus and V naught plus? So for that we will use these two equations. Okay, so here we have the at load voltage is VL, so V naught plus e to the power minus gamma L plus V naught minus e to the power plus gamma L, and this is your IL into Z naught V naught plus e to the power minus gamma L minus V naught minus e to the power gamma L. So if we suppose add them, if I add them, then these two will get cancelled and we will get the equation as the when we add these two equations, right? So V naught plus is equal to VL plus IL into Z naught divided by 2, and similarly we will get V naught minus is equal to VL minus IL into Z naught divided by 2. Okay. Yes, right now I'm taking IIT Tirupati. Okay, Sandesh. Yes, Sandesh, you can call me, no issue. And at most numerical questions from the electromagnetic theory in GATE, we can expect. Yes, almost every questions will be numerical in the electromagnetic theory. How much of the marks should we expect? Okay, you see, it is difficult to say, but yeah, I will say that at least 5 questions you will definitely get from the EMFT, which will be covering around 7 to 8 marks minimum side, and it can go up to the 12 marks maximum side. So the range of the EMFT for EC student is from ranging from 8 to 12 marks. So 8 to 12 marks you can expect. Yes, you can expect the question in the BEL, Bharat Electronics Limited will have the question from the MFT. Okay. So now you will put the values of V naught minus. So what is the value of V naught minus? The V naught minus is VL minus IL into Z naught divided by 2. And then we will get, when you add this, okay, when you added this, there was one more term that is coming. When you add, it will be e to the power plus gamma L, and when you subtract them, it will be e to the power minus gamma L. So V naught minus will have e to the power minus gamma L. So e to the power minus gamma L will also be there, and divided by VL plus IL into Z naught divided by 2 e to the power plus gamma L, and here we have a 2 gamma L. Okay, then this e to the power gamma L minus gamma L and 2 gamma L will get cancelled. So we will get the VL minus IL Z naught, and 2 and 2 will also get cancelled. So VL plus IL into Z naught. So because this is the load impedance, load voltage, so we can write IL into the load impedance minus IL into the characteristic impedance. This is IL into the load impedance plus IL into the characteristic impedance. So IL will get cancelled. So reflection coefficient is ZL minus Z naught divided by ZL plus Z naught. So that is the reflection coefficient you are getting. And this reflection coefficient, at which point we have calculated, this reflection coefficient is at load. Okay. This is the reflection coefficient at load. Now, suppose you want to calculate the reflection coefficient at any distance L dash from the load, then what will be the value? Reflection coefficient at any distance L dash from the load. Can you tell me? Reflection coefficient at any distance L dash from the load, can you tell? So suppose we have a transmission line like this. Okay, suppose you have a transmission line. Now you want to calculate the reflection coefficient, not exactly at the load. You want to calculate that at some particular distance from the load. Okay, that is Zg, this is generator Vg, and that is ZL. Now we want to calculate the reflection coefficient at any distance L dash from the load. This is load. Okay, that is Z is equal to 0 and that is equal to L. So that is the total length L. So this distance would be L minus L dash. Okay, L minus L dash. Now to calculate this, the VSZ equal to L minus L dash now, because now when you measure the distance from the source side, that is the L minus L dash, because the total distance is L and you want to calculate at any distance L dash. So you want to calculate the reflection coefficient at this point, gamma L dash, and you have the value at this point, which is gamma load. At the load we have calculated the value, which is ZL minus Z naught divided by ZL plus Z naught. Yes, so let's try this. V naught plus e to the power minus gamma L minus L dash, right? And then it is V naught minus e to the power plus gamma L minus L dash. And this is your current Is at the same point, L minus L dash, that is V naught plus divided by Z naught e to the power minus gamma L minus L dash minus V naught minus divided by Z naught e to the power gamma L minus L dash. So these are the two equations. Now when you take the reflection coefficient at any distance L dash, you will again calculate the reflected voltage divided by incident voltage. So this is the V naught minus e to the power gamma L minus L dash divided by V naught plus e to the power minus gamma L minus L dash. So this is V naught minus divided by V naught plus e to the power gamma L and e to the power minus gamma L dash divided by e to the power minus gamma L into the power plus gamma L dash. So now this is V naught minus divided by V naught plus e to the power 2 gamma L and e to the power minus 2 gamma L dash. So e to the power V naught minus divided by V naught plus V naught minus divided by V naught plus e to the power plus 2 gamma L is nothing but the reflection coefficient at the load end. So this part is nothing but the reflection coefficient at the load end. So now we can say that the gamma L dash is nothing but the reflection coefficient at the load end and e to the power minus 2 gamma L dash. Okay, that is the value. Now you have got this. Okay, so we have got the formula. Reflection coefficient at any distance L dash from the load is reflection coefficient at the load and e to the power minus 2 gamma L dash. Okay, that is the value. Now for lossless transmission line, okay, for lossless transmission line, for lossless transmission line, you will say alpha equal to 0. So gamma is equal to alpha plus j beta, and hence we will put gamma is equal to j beta. So reflection coefficient at any distance L dash is reflection coefficient at load e to the power minus 2 j beta L dash. So this is reflection coefficient at load e to the power minus j 2 beta L dash. Okay. So now just tell me what will be the reflection coefficient in this case. This is your transmission line. Okay. This is your transmission line. And we have a load like this. Okay. This is the load 100 ohm. This is the characteristic impedance 50 ohm. If we want to calculate the reflection coefficient at this point, and if this is the distance or the length of the transmission line is lambda by 4, then what will be the reflection coefficient? What will be the reflection coefficient? What is the answer of this question? One by 3 or minus 1 by 3. Okay. So as I told you that first of all you will calculate the reflection coefficient at the load. So reflection coefficient at the load is ZL minus Z0 divided by ZL plus Z0, which is 100 minus 50 divided by 100 plus 50. So you are getting 1 by 3. But because I asked you to calculate the reflection coefficient at the input side, so reflection coefficient at any distance L dash from the load side is nothing but the reflection coefficient at the load and minus 2 j beta L dash. If nothing is given, then definitely it will be a lossless. So 2 beta L dash. So reflection coefficient we have calculated, which is 1 by 3. So minus j 2 beta. Beta is 2 pi by lambda and L dash is lambda by 4. So it is the 1 by 3 e to the power minus j pi. And 1 by 3, this is cos pi minus j sin pi. So this cos sin pi is 0, cos pi is minus 1. So this is minus 1 by 3. So reflection coefficient at the input side is minus 1 by 3. So the answer will be minus 1 by 3. Minus 1 by 3 will be the answer. Okay, Vikram? Have you got this? Minus 1 by 3 would be the answer. Guys, there is a workshop, ideal strategy to be a topper in the GATE 2025 in the December to 7:30, and there is a scholarship test on Sunday. You can register for that. So that is the question that Vikram asked. A transparent dielectric coating is applied to glass to eliminate the reflection of the red light. The minimum thickness of the dielectric coating in micrometer that can be used. So here we are saying that we have three different mediums in this way, that this is the glass first. So now we have a coating of the dielectric in this particular region, and it is a air. So this part is now becoming air. Okay, that is the air part. If nothing is given, that where it is going, so we can say that it is air, and here it is glass, and here it is dielectric. So the same concept of the transmission line we have to apply. What is the concept of the transmission line? That if you want to match the two impedance, then you will have to use the transmission line of length lambda by 4 or odd multiple of lambda by 4, which should have the characteristics of equal to geometric mean of the impedance to be matched. Okay. Okay, so here the thickness is, we have to use D, and this D should be lambda by 4 or odd multiple of lambda by 4. Okay, it should be the odd multiple of lambda by 4 as we use in the transmission line. How many of you know that how do we perform the matching with the help of the transmission line of length lambda by 4? By the help of the quarter wave length, we can avoid the reflection from the road. But the condition of the quarter wave length is the characteristic impedance of the quarter wave length should be the geometric impedance, geometric mean of the impedance to be matched. So here in the waveguide, the impedance of the dielectric should be geometric mean of the impedance of the glass and impedance of the air. Okay, so what is the geometric mean for the for this? Because we know that this eta is nothing but the 120 pi and root over mu r divided by epsilon r. So it is what? It is inversely proportional. So we can write this as a 1 upon root over of epsilon r of dielectric. So in this way, we will write epsilon r of dielectric. So this is root over of 1 upon root over of epsilon r of the glass and root over epsilon r of the air. So because this root and this root will get cancelled, and hence we will get, okay, we will get epsilon r is equal to root over epsilon of glass and epsilon of air. So because the epsilon of glass is 4 and air will have 1, so the epsilon R for the dielectric will be 2. Epsilon R for the dielectric will be 2. So that is clear. Geometric mean of Z0 and ZL, yes. Up to this point, tell me whether it is clear or not. Okay. Now, because it is asking for the minimum thickness we have already said that it should be this, and lambda is equal to Vp upon F, and Vp is nothing but the velocity of light divided by root over epsilon r. Because the lambda naught is given, so we can write C by F as lambda naught divided by root over epsilon r. So lambda is equal to lambda naught, that is 0.75, divided by root over epsilon r, that is root 2. So 0.75 divided by root 2 we can perform, and you will get the lambda. So it is coming as 0.53. 0.53 is coming, and here we are saying that for the minimum thickness, n equal to 0, so we will get d is equal to lambda by 4. So whatever we are getting, we have to divide it by 4. So it is coming as 0.13. The distance is coming as 0.13. Okay, 0.13. Up to 2 decimal it is asking, then it is 0.3. Lambda is equal to 0.53 micrometer, and the answer will be coming in the micrometer only. Okay. Yes, 0.1325. So we can approximate it to 0.13 up to 2 decimal. Clear, Vikram? Now solve this question. Yes, it is the impedance matching only. It is impedance matching only, yes. It can be asked for the wave propagation as well. A lossless transmission line is terminated in a load which reflects a part of the incident power measured in the VSWR is to the percentage power that is reflected. What is the value? The percentage power that is reflected. Okay, so we know that the VSWR and the gamma is rated as 1 plus magnitude of gamma divided by 1 minus magnitude of gamma. So from here we can write that this is VSWR minus 1 divided by VSWR plus 1. It is going to give a magnitude of gamma. So it is 2 minus 1 divided by 2 plus 1, which is 1 by 3. Okay, so 1 by 3. So the percentage power reflected is given by mod gamma square. So percentage gamma square, that is 1 by 9, and it is asking in the percentage, so multiplied by 100, it is 11.11%. Yes. So answer is D. Now guys, there is an open mock test also free of cost. So I hope that all of you are attending this mock test. You will get a good number of questions, and you will also get an idea that how to solve the questions in the given time. Now, statement for the question 1 and 2. This is the voltage standing wave pattern in a lossless transmission line. This is the lossless transmission line. Characteristic impedance is 50 ohm. The resistive load is shown in figure. So this is the standing wave pattern, and the load it is given. This is the value 1 and this is the value 4. And this is the lambda by 2. This is lambda. What it is asking for, the value of the load resistance. The value of the load resistance and the reflection coefficient. So there are two questions. The value of the load resistance. What will be the value of the load resistance? 1 माइनस गामा स्क्वायर होगा अनंत. 1 माइनस गामा नहीं होगा, 1 माइनस गामा स्क्वायर होगा, मतलब कि 8/9. 1/9 आया था तो 1 माइनस 1/9 कर लेना, तो 8/9 आ जाएगा. What is the load resistance? 12.5. ठीक है. So here you can see that the standing wave ratio is maximum voltage divided by minimum voltage, which is 4. And because the voltage minima is occurring, okay, the voltage minima occurs, okay, the voltage minima occurs at load, at load. That means the load resistance is less than the characteristic impedance, and because the standing wave ratio is given by Z0 upon ZL in such cases, the load resistance is Z0 divided by S. Z0 is 50 divided by S. S is 4, so it is 12.5. So 12.5 ohm is the right answer. 12.5. Yes, everybody has given the 12.5. And the reflection coefficient, is ZL minus Z0 divided by ZL plus Z0, because the standing wave ratio is what should I say? Because the reflection ZL you have already got, so this is 12.5. Okay, this is 12.5 minus 50 divided by 12.5 plus 50. You will get minus of 3/5. That is 0.6. So minus of 0.6. That is the option A. Correct. Now answer this question. Answer this question. 10 ohm. Okay. Option A, 10 ohm. Yes. So almost the same thing. Here also the VSWR is 5. So by which you will get the gamma, that is mod of gamma, 5 minus 1 divided by 5 plus 1, which is nothing but a 4 by 6, right? 2 by 3. Okay, sorry. It does not require, let it be. Because you can see that the exactly from the load when you travel the lambda by 4 distance, it is giving you the voltage minima, voltage maxima. That means at the load you are getting voltage minima. So when you are getting the voltage minima, again the standing wave ratio will be Z0 upon ZL, like a previous question. So the load resistance is Z0 divided by S, and Z0 is 50 and S is 5. So it is 10 ohm. Yes. So 10 ohm is the right answer. Now answer this question. Yes, Anand, perfect. Yes, right approach. Right approach, Anand. Brewster angle in parallel and series in reflection. Brewster angle in case of plane wave propagation, Ankit, are you asking for the plane wave propagation? Because parallel and series in reflection, I am not understanding series, parallel polarization and perpendicular polarization. Brewster angle. See, when you have to make the reflection zero, na? Actually, it is a big topic. So, first of all, how much it is clear with 5 by 7. Okay. Anand is saying 5 by 7. So here we can say that the input impedance for this line, if I calculate the Zn1, which is because lambda by 4 is given, so there is not square upon ZL, that is 50 into 50 divided by 100, you will get 25. And here when you calculate Zn2, this is again 50 into 50 divided by 200. Okay, 50 into 50 divided by 200. So it is nothing but a 12.5. So these two are in parallel. So the load impedance will be Zin1 in parallel with Zin2. So 25 in parallel with 12.5. So 25 in parallel with 12.5 you will calculate. So how much it is? It is, I think, 25 by 3. So 25 by 3 you are getting. So now the 25 by 3 minus 50 divided by 25 by 3. Okay, wait. Yeah. So this is 25 by 3 plus 50. So it is the 125 with minus sign, and it is 175 with plus sign. So you are getting minus 5 by 7. But minus 5 by 7 you are getting at load. Reflection coefficient at load is minus 5 by 7, but it is asking the reflection coefficient at the input side, and we have lambda by 4 length. So we know that the lambda by 4 length inverts the everything, that is reflection coefficient at the load. If it is positive, then it is inverse in phase. So the answer is plus 5 by 7. Okay, the same thing we have already done when I told you about this concept. Here we discussed this, right? So because of this lambda by 4 length, whatever you are getting at the load side, when you are going into the input side, it get inverted. So if you are getting negative, then it will become positive. If you are getting positive, then it will become negative. Okay. So here you are getting the minus 5 by 7. So at the input side, it will become a plus 5 by 7, right? Now answer this question. What you are getting? So in the circuit shown in figure, all the transmission line sections are lossless. The voltage standing wave ratio, you have to calculate the voltage standing wave ratio is. So first of all, you will calculate for this. So this is the input side. So suppose you are calculating at this side. So Z in 1 is Z0 square upon ZL again. So here you will get the Z0 square means 30 root 2 whole square divided by ZL, which is 30. So you will get the 30 into 2. So you are getting 60 ohms. Okay, now we are calculating for this. So this is Z in 2 because it is lambda by 8. So this is Z0 plus ZL plus JZ0 divided by Z0 plus JZL. Since it is short circuited, so load is 0, Z0 will get cancelled. We will get JZ0, which is J30. So J30 we will get, these two are in series. So this is Z in 2 and the Z in 1. So the overall Z load is the series combination Z in 1 plus Z in 2. So these two are connected in series. So we are having 60 plus J30. Okay. So this is the load impedance. Now because we want to calculate the standing wave ratio is 1 plus mod gamma divided by 1 minus mod gamma. So we need to calculate the gamma, magnitude of gamma. So how do you calculate the mod of gamma? ZL minus Z0, that is 60 plus J30 minus 60 divided by 60 plus J30 plus 60. So this 60 and 60 will get cancelled, and this is J30 divided by 30 is also common. So it is the 4 plus J. So it is coming around 1 upon root 5. 1 upon root 17. 1 upon root 17. So 1 plus 1 upon root 17 divided by 1 minus 1 upon root 17. You will get 1.64. How many of you got this answer? 1.64. 1.64 will be the right answer. Okay, 1 upon root 17. How do we get this 1 upon root 17? I hope that there is no doubt in this. First, I will write it here again, because the gamma is equal to J30, and here we are having 120 plus J30. When you take common, 1 plus 1 upon 1 plus 1 upon 1 4 plus J. So that is root 17 mod of gamma. ओके, ठीक है. सो कोई बात नहीं, आगे आपको समझ में. नेक्स्ट अपन चलते हैं. गाइस, वी हैव ए बायजूस एग्जाम प्रेप ऐप, है ना. देयर इज अ ऐप आल्सो, यू कैन डाउनलोड एंड यू कैन गेट द any free sessions also. I have one session today at 8 o'clock, 9 o'clock, so you can join that session also. There is a multi-subject test at 8 p.m. today. Sorry, at 9 p.m. today. I have a multi-subject test. Okay, so there will be a multi-subject test in which there will be a test of maybe the control and signal, maybe the digital and the analog, like that. So multi-subject test is there in the app. So you can download our BYJU'S exam prep app. Okay, this is the app, and in this way we get the leaderboard and you will see that where you are landing. And this is the course that we have launched, Vision 25 and 26. And this is my Telegram group. Okay, so you can join my Telegram group also. So now we will come to the S parameter part. So how many of you are aware about the S parameter? First of all, tell me how many of you are aware about the S parameter. Have you ever studied that? Have you ever studied that? Just comment in the comment section that how many of you know about the S parameter. Yes, आज होगा टेस्ट. Okay, Vikram. Yes, Manasvi. So आप जानते हो. Okay, so now here we will get the incoming wave, and that is the reflected wave, which is B1. So the incident wave is A1, the reflected wave from the port 1. This is the port number 1. So we will have to discuss only the 2 port for the S parameter. So for the first port, the port number 1 is having the characteristic impedance Z0 1, because these two are the different transmission line. Okay, the input side we have a different transmission line, and at the output side we have a different transmission line. So because of that, there will be a 2 different characteristic impedance of the line. The incident wave is A1, the reflected wave is B1. The incident wave from port number 2 is A2, the reflected wave is B2. So how do you write वोल्टेज मैक्सिमा और वोल्टेज मिनिमा का फॉर्मूला? ओके, ठीक है, उस पर भी आते हैं. अगर हम बात करें कि B1 इज इक्वल टू S11 A1 प्लस S12 A2 होगा, एंड B2 इज इक्वल टू S21 A1 प्लस S22 A2 होगा. ठीक है, तो ये हमारा फॉर्मूला है. अगर मान लो आपको एस पैरामीटर 1 निकालना है, तो आपका क्या होना चाहिए, ये B1 अपॉन A1 होना चाहिए when A2 इक्वल टू 0. ठीक है, अगर आपको सपोज S12 निकालना, जैसे आप नेटवर्क में निकालते हो, B1 अपॉन A2 करना पड़ेगा प्रोवाइडेड A1 शुड बी 0. जब आप A2 को 0 करोगे तो आप और क्या कैलकुलेट कर सकते हो, S21 भी कैलकुलेट कर सकते हो. ठीक है, A2 को 0 करने पे. और जब आप A1 को 0 करोगे तो आप S22 भी कैलकुलेट कर सकते हो, B2 अपॉन A2 when A2 is 0. ठीक है, तो ये जो B1 है B2 है, ये क्योंकि सारे रिफ्लेक्टेड वेव्स हैं, जो ये वेव्स हैं इसको हम लोग नॉर्मलाइज्ड फॉर्म में लिखते हैं. जैसे कि अगर आपको लिखना है B1, तो ये रिफ्लेक्टेड वेव है ना, नॉर्मलाइज्ड रिफ्लेक्टेड वेव. तो नॉर्मलाइज्ड रिफ्लेक्टेड वेव मैं लिख देता हूँ, नॉर्मलाइज्ड रिफ्लेक्टेड वेव एट पोर्ट नंबर 1. normalized reflected wave at port number 1. सो पोर्ट नंबर 1 में ये नॉर्मलाइज्ड है, तो नॉर्मलाइज्ड कितना हो गया, V0 रिफ्लेक्टेड वेव ना, सो V1. ठीक है, ये V1 हो गया रिफ्लेक्टेड वेव, V1 माइनस डिवाइडेड बाय रूट ओवर कैरेक्टरिस्टिक इम्पीडेंस. कैरेक्टरिस्टिक इम्पीडेंस से डिवाइड करने पे उसको नॉर्मलाइज करते हैं. सिमिलरली आप कैलकुलेट कर सकते हो, चाहो तो A1 भी लिख सकते हो. A1 इंसिडेंट वेव है तो V1 Z01. अगर आपको B2 लिखना है तो आप लिखोगे V2 माइनस डिवाइडेड बाय रूट ओवर कैरेक्टरिस्टिक इम्पीडेंस. अगर सपोज आपको A2 लिखना है तो आप लिखोगे V2 प्लस इंसिडेंट वेव एंड डिवाइडेड बाय कैरेक्टरिस्टिक इम्पीडेंस, दैट इज Z02. ठीक है, अब यहाँ पे जैसे वैल्यू सब्स्टिट्यूट करेंगे और हम लोग यहाँ पे ये S11 अगर सपोज इसी वे फॉर्म में कैलकुलेट करना चाहते हैं वोल्टेज के फॉर्म में, तो ये S11 क्या होगा, B1 अपॉन A1. तो B1 यानी V1 माइनस डिवाइडेड बाय रूट ओवर कैरेक्टरिस्टिक इम्पीडेंस ऑफ द फर्स्ट लाइन. A1 इज V1 प्लस, तो रूट ओवर कैरेक्टरिस्टिक इम्पीडेंस ऑफ द फर्स्ट लाइन, दोनों कैंसिल हो गया. तो S11 क्या आ गया, V1 माइनस डिवाइडेड बाय V1 प्लस. ये क्या बन गया, आपको कैसा दिख रहा है, V1 माइनस जो है वो रिफ्लेक्टेड वेव है और रिफ्लेक्टेड वोल्टेज वेव है, और V1 प्लस क्या है, इंसिडेंट वोल्टेज वेव है. तो क्या बन गया, रिफ्लेक्शन कोफिशिएंट. तो S11 इज नथिंग बट द रिफ्लेक्शन कोफिशिएंट एट द पोर्ट 1. ठीक है, सिमिलरली यू कैन राइट फॉर S22 एंड S21. सो फाइनली इवन जब आप सब लिख लोगे, है ना, तो मैं आपको क्विकली बताता हूँ क्योंकि वी हैव लेस टाइम फॉर दिस. सो नाउ यू कैन राइट, जहां पे आप B2 लिखे थे वहां पे आप लिख लो V2. B2 था रिफ्लेक्टेड वेव एट पोर्ट नंबर 1, सॉरी इसको पोर्ट नंबर 1 पे लिखना है, रिफ्लेक्टेड वेव एट पोर्ट नंबर 1. तो V1 माइनस, ठीक है, तो यहां से आ जाएगा आपके पास V1 माइनस इज इक्वल टू S11 इंसिडेंट वेव एट पोर्ट नंबर 1 V1 प्लस एंड S12 इंसिडेंट V2 प्लस. फिर यहाँ पे लिख लो V2 माइनस पोर्ट नंबर 1 पे, पोर्ट नंबर 2 पे रिफ्लेक्टेड वेव, S21 इनपुट था V1 प्लस एंड S22 इनपुट है पोर्ट नंबर 2 पे V2 प्लस. तो ये हमारा ओवरऑल वोल्टेज और का इक्वेशन बन जाएगा फॉर एस पैरामीटर. Is the reflection coefficient at the input side or at the network side? At the input side means नेटवर्क के इनपुट साइड पे. मतलब आप इनपुट नेटवर्क के ही इनपुट साइड में बोलोगे, नेटवर्क जो भी नेटवर्क रहेगा उसके इनपुट साइड पे, नेटवर्क के इनपुट साइड पे. यस कृष्णा, गुड इवनिंग. ठीक है, आकांक्षा आप फॉर्मूला पूछ रहे थे तो एक बार हम लोग देख लेते हैं मैक्सिमम का फॉर्मूला. तो मैक्सिमम का फॉर्मूला होता है पाई प्लस 2n पाई अपॉन बीटा. ठीक है, 5 प्लस 2n अपॉन 5 बीटा फॉर n equal to 0 1 2 and so on, for pi greater than equal to 0 and n is starts from 1, 2, 3 and so on for phi less than 0. ये 2 बीटा है, phi plus n pi, phi plus n pi. ठीक है, जब पहला रखेंगे तो फाइव अपॉन 2 बीटा, फिर 1 रखेंगे तो 5 प्लस पाई अपॉन 2 बीटा, ऐसा करके हम लोग निकाल सकते हैं, है ना. मैक्सिमा से मिनिमा के बीच का डिस्टेंस हमारा लैम्डा बाई 4 आना चाहिए. सो पाई बाई लैम्डा आना चाहिए. एक सेकंड रुको, ये तो ठीक था. जेड मैक्स ना, जेड मैक्स 5 प्लस 2 एन पाई ठीक था, मतलब 5 प्लस एन पाई और मल्टीपल ऑफ पाई लिखना पड़ेगा, देन डिवाइड बाय लैम्डा. बताओ मेरे को एस पैरामीटर के बारे में बताओ पहले कि यहाँ तक आपको क्लियर हुआ क्या, फिर मैं आपको और आगे चल के ये मैक्सिमम और मिनिमम का फॉर्मूला मैं आपको कैसे आप लिखोगे फाई के टर्म्स में, आप कैसे लिखते हो आपको ये पता ही होगा फाई के टर्म्स में. सर सर्किट में वी जनरेटर एंड इम्पीडेंस दिया हो तो जेड इन और लोड करंट क्या होगा. क्वेश्चन नहीं समझा सर. सर्किट में वी जनरेटर एंड जनरेटर इम्पीडेंस दिया हो तो जेड इन किस केस में पूछ रहे हो. ये एस पैरामीटर के केस में. ठीक है, ये मैक्सिमा का जो फॉर्मूला अपन लिखे थे सही लिखे थे ना, 5 प्लस 2 एन पाई डिवाइडेड बाय 2 बीटा, याद आ गया. और अगर मिनिमा लिखना है एल डैश फ्रॉम द लोड एंड तो मैक्सिमा प्लस माइनस लैम्डा बाय 4 करना पड़ता है डिपेंडिंग अपॉन द डिस्टेंस जो आप कैलकुलेट करते हो ना, जो मैं बताया था. 5 ग्रेटर देन इक्वल टू 0 रहेगा तो n 0 1 से स्टार्ट होगा, और 5 लेस देन 0 रहेगा तो n 1 से स्टार्ट होगा. ठीक है. अच्छा, इनपुट ट्रांसमिशन लाइन के केस में ना, अभी रुको उसको हम लोग डिस्कस करते हैं. पहले हम लोग ये जो प्रेजेंट में एस पैरामीटर को हम थोड़ा सा डिस्कस करना चाह रहे हैं वो कर लेते हैं. ठीक है, यहाँ तक क्लियर है विक्रम. जैसे विक्रम को एस पैरामीटर के बारे में आइडिया नहीं था, तो यहाँ तक आपको समझ में आया कि क्या क्या हो रहा है, कैसे आप किसी एस पैरामीटर की वैल्यू निकालते हो. जैसे आपने नेटवर्क में पढ़ा है वैसे ही हम लोगों ने ये इक्वेशन लिखा है, जहाँ पे नेटवर्क में आपके पास वोल्टेज और करंट होते हैं. यहाँ पे आपको फॉरवर्ड वोल्टेज और फॉरवर्ड करंट, रिवर्स वोल्टेज और रिवर्स करंट के टर्म्स में लिख लेना है. करंट नहीं है, वोल्टेज वोल्टेज है बस. ठीक है, अब इसका जो पहला प्रॉपर्टी है, क्या प्रॉपर्टी होता है कि एस पैरामीटर क्या है, एक पहला प्रॉपर्टी क्या है, एस पैरामीटर एक स्क्वायर मैट्रिक्स होता है. ठीक है, और इसका ऑर्डर जो होता है ऑफ ऑर्डर एन क्रॉस एन, ऑफ ऑर्डर एन क्रॉस एन, मतलब अगर दो पोर्ट है ना, एन जहां पे क्या है नंबर ऑफ पोर्ट, नंबर ऑफ पोर्ट्स. ठीक है, सेकेंड प्रॉपर्टी आपके पास आ जाता है एस, और अगर एस ट्रांसपोज मतलब एस मैट्रिक्स और एस ट्रांसपोज. एस मैट्रिक्स क्या है, एस मैट्रिक्स आपका क्या बन जाएगा यहाँ पे, एस मैट्रिक्स S11 S12 S21 S22. ठीक है, ये अच्छा. अब एस मैट्रिक्स क्या है, अगर एस इक्वल टू एस ट्रांसपोज है तो उसको हम लोग कौन सा नेटवर्क बोलेंगे, रेसिप्रोकल. ठीक है, अगर किसी नेटवर्क का एस पैरामीटर और उसका एस ट्रांसपोज अगर सेम हो तो रेसिप्रोकल. एस आई जे इज इक्वल टू एस जे आई है तो सिमेट्रिकल. ठीक है, और फोर्थ है कि लॉसलेस कब बोलेंगे, नेटवर्क इज सेट टू बी लॉसलेस. ठीक है, इसके लिए आपको क्या करना है, एस मैट्रिक्स का कॉम्प्लेक्स कॉन्जुगेट और एस, इसको आप ऐसे लिख लो, एस ट्रांसपोज, एस मैट्रिक्स का ट्रांसपोज और एस मैट्रिक्स का कॉम्प्लेक्स कॉन्जुगेट, एस मैट्रिक्स का ट्रांसपोज एंड एस मैट्रिक्स का कॉम्प्लेक्स कॉन्जुगेट. अगर इन दोनों का मल्टीप्लीकेशन आइडेंटिटी मैट्रिक्स आता है तब उसको हम लोग लॉसलेस बोलते हैं, ठीक है। तो अगर हम इसको देखें तो इस टू पोर्ट नेटवर्क के लिए अगर मैं ट्रांसपोज ले लूँ तो 1 1 1 2 आ जाएगा और ये 2 1 और 2 2 आ जाएगा, ठीक है। और एस मैट्रिक्स का कॉम्प्लेक्स कॉन्जुगेट लोगे तो S11 कॉम्प्लेक्स कॉन्जुगेट, S12 कॉम्प्लेक्स कॉन्जुगेट, S21 कॉम्प्लेक्स कॉन्जुगेट, S22 कॉम्प्लेक्स कॉन्जुगेट आ जाएगा। इसको अगर आप मल्टीप्लाई करोगे तो S11 का स्क्वायर, S21 का स्क्वायर, है ना, ऐसा आ जाएगा और दिस शुड बी इक्वल टू 1, ठीक है। या आप ऐसा बोल सकते हो S12 स्क्वायर एंड S22 स्क्वायर दैट शुड बी इक्वल टू 1। तो टू पोर्ट नेटवर्क के लिए अगर आप देखो, है ना, फॉर टू पोर्ट नेटवर्क, यस, लॉसलेस मतलब ये हो जाएगा। $35 marks, it depend करता है that whether you have good command over those subject or not. Okay, so first of all, whenever you have to prove the two port network to be lossless, okay, that in terms of S parameter, if you want to prove it in the whether it is lossless or not, then आप क्या कर सकते हो, you can take the फर्स्ट कॉलम, है ना, आप क्या कर सकते हो, फर्स्ट कॉलम ले सकते हो और उसके वैल्यूज का स्क्वायर करके ऐड कर सकते हो। first column, take the first column and square it and add them. If you are getting 1, then it is a lossless. If you are not getting 1, then it is a lossy. Okay, either आप फर्स्ट रो भी ले सकते हो, फर्स्ट कॉलम भी ले सकते हो, कोई दिक्कत नहीं है, बिकॉज अल्टीमेटली वो सेम ही आएगा। चाहे आप जो आपका ओरिजिनल एस मैट्रिक्स है उसके फर्स्ट कॉलम का स्क्वायर करके ऐड कर लो या फर्स्ट रो के एलिमेंट्स का स्क्वायर करके ऐड कर लो। इफ यू आर गेटिंग 1, then it is lossless. If you are not getting 1, then it is lossy. That is the fourth point. Okay. Yes. Okay. So these are the four important properties related to your S matrix. So in the S parameter, that is the thing that you should be aware of. And there are many things, but because time is not permitting, that I am not able to discuss for this. How do you calculate the S parameter for the series and the shunt element? We will do that in the marathon session when we will be having the marathon session in the next month. Then we will discuss more about this S matrix. Okay. So thank you for watching this session. We will meet tomorrow. Tomorrow we will be discussing the rectangular waveguide and the circular waveguide. So we will be covering these two waveguides tomorrow in the 1 hour. So just be ready to revise these two waveguides at the same time, 7 p.m. 7 p.m. to 8 p.m. we will have 1 hour session. Thank you. Thank you so much. Yeah, you can refer the book for the S parameter, that is your microwave books you will get. The microwave books, and the author name is Liao. That Liao book you can follow if you want to go through the books for the S parameter. And there's one more book, that is Poser.